Okay, next will be step response of RC circuit. If we consider source free RL and RC circuit in where there is no supply in the voltage or current in the circuit, but instead the stored energy from capacitor or inductor, in which that provide the energy in the circuit. This time, if we consider step response of RC circuit, there are supply in the circuit, which is DC source. When DC source of an RC circuit is suddenly applied, the voltage or current source can be modeled as a step function, and the response is known as step response. So, a step function. Okay, let's say nga, if natay gi-apply suddenly nga voltage or current source such as DC source, then kato nga DC source pwede daw ma-model as step function. So that is what he mean by step function. Okay, definition. The unit step function of t is equal to 0 for negative value of t and 1 for the positive value of t. In this sample that I graph, in step function of t is equal to 0 if yung t is less than 0. If less than 0, yung unit step function niya is naa dire. If equal po yung step function sa 1 when t is greater than 0. So, greater than 0. T is greater than 0. Where step function niya is naa dire. Na point. Okay. Next is pwede po mag-start ang t nato in other nga value, not other than 0. So, pwede nato nga t is equal to t naught, where muni atong definition. Okay. So, step function of t or u of t minus t naught minus is equal to 0 when t is less than t naught. Okay. Muti atong t naught. Okay. And step function of t naught is delayed by second. So, diri nag-start atong step function. Okay. When kando, so equal to 0 if t is less than t naught. So, less than t naught is diri siya mag-start or diri yang function. And if equal to 1 na po yung step function when t is greater than 0. So, diri kuha is greater than 0. Let's consider an RC circuit with a specific DC source or RVS. Okay, the step function or the step response of a circuit is its behavior when the excitation is the step function or DC source, which may be a voltage or current source. So, diri nga circuit natay DC source, resistance, switch, o capacitor. At t is less than 0, open pa ang switch, and at the point nga na-reach na niya ang t is equal to 0, na-close na ang switch, which is gani na lang. Gani nga figure. So, if we consider at time is equal to 0 and VO is equal to V naught when time is equal to 0. Let's find the voltage response in the capacitor given in this formula. So, V of 0 negative when the switch is when the time is less than 0 and the moment that the switch is open. And equal na siya sa V of 0 positive. Okay? When t is equal to 0, the switch is close. Close na siya. And equal sila sa 0. Okay. Let's make equation based diri nga circuit. So, let's use nodal analysis, which is node V. Let's say that node V. So, ang current sa resistor is leaving also sa capacitor. And summation of I is equal to 0 at node V. And summation of I leaving is equal to summation of I entering. So, closed loop na siya. Closed loop. So, let's say nga, ang capacitor is I of C plus high potential V minus lower potential Vs. Divide R is equal to 0. Okay? Ang entering is wala man. Leaving man duha. So, 0 ang entering. Kung ato ning evaluate ng current sa capacitor, according sa ito sa capacitor, is C is dV over dt plus V minus Vs over R is equal to 0. And divide nato siya sa C, where cancel V, C, cancel na siya, and mabili na lang is gani. So, dV over dt plus V minus Vs is equal to, over RC is equal to 0. And transpose na to ng Vs minus, V minus Vs over RC is transpose na to this left side, right side. And dV over dt minus V minus Vs over RC. And cross multiply ning duha, so we can get dV over V minus Vs minus dt over RC, which is integrate na to both side. So, integral of dV over V minus Vs is equal to negative dt over RC, and can get ln of V minus Vs is equal to negative 1 over RC T plus C, where atong C constant is the condition nga if T is equal to 0, V of 0 is equal to V naught. And ito na siyang i-substitute. So, substitute na nato. Dili So, ln V naught minus Vs is equal to 1 over RC times 0 plus C. Which is kani siyang 1 over negative 1 over RC is 0 na, makancel na. Ang mabili na lang is ln of V naught minus Vs is equal to C. And substitute na to dire na pod, ibalik na to dire. So, ln of V minus Vs is equal to negative 1 over RC T plus ln V naught minus Vs, which is ato ning transpose dire sa left side. So, you can get ln of V minus Vs minus ln V naught minus Vs is equal to negative 1 over RC T. Okay. Using quotient rule of logarithm, ini dua this. So, ln of V minus Vs over V naught over minus Vs is equal to negative 1 over RC T. And let's make this both a exponent. Aron, cancel na siya. So, ang mabili lang is V minus Vs over V naught minus Vs is equal to e raised to negative T over RC, which is atong constant time sa capacitor is tau. So ito ni substitute lang diri, and V minus Vs over V naught minus Vs is equal to e raised to negative t over tau. So kung ato tong i multiply by both sides of V naught over Vs, can get, which is wala ni siya, maka-cancel, which is V minus V sub s is equal to V naught minus Vs times e raised to negative t over tau, which is kung atong is transpose ning V over s is V is equal to V over s plus V naught minus V over s times e raised to negative t over tau. And we can get this one, which is muna itong definition, which is V of t is equal to, when V naught kay muna itong initial value sa capacitor when t is less than 0, and Vs plus V naught minus Vs times e raised to negative t over tau is when the t is greater than 0. Okay, kung ato itong i-graph, so step response of an RC circuit with charged capacitor, and this is our initial value sa itong V naught. So V naught is equal to 0 when t is less than 0. So when t is less than 0, so nadiri ang value, which is pa naka-charge. So when t is greater than 0, dire greater than 0 is exponentially increasing yang waveform until ma-reach niya niyang V of s, or yang source, which is Vs plus 0 minus Vs times e raised to negative t over tau, which is atong simplify is we can get this one, Vs minus Vs e raised to negative t over tau when time is greater than 0, or simplifying more, makawas ning kan Vs both, so Vs times 1 minus e raised to t minus over tau, and this is final outcome. So next, step response of an RC circuit with initially uncharged capacitor. So sa voltage response, initially uncharged, so wala siya voltage. When time is less than 0, which is dire siya mag-start. When time is greater than 0, and exponentially increase yung waveform like this till reach yung voltage source or DC. And step response of an RC circuit with initially uncharged capacitor. So sa current response na punta. So muna yung initial value sa yung current, so sa maximum. Kung so sa time less than 0, nadi yung value when the time is greater than 0, so dira yung exponential decay will be obvious, so mag-lower like this, ma-decrease till equal to 0. Okay, this one, so atong natural response sa current response nato sa capacitor will be I of t is equal to c dv over dt is equal to c over tau o times vs times e raised to negative t over tau, where nahay tay constant time nga if ang tau na to is equal to RC, which is ang tau na to ilisan na to RC, which is C over RC times Vs e raised to negative t over tau, and cancel na siya, and we can get this one. So Vs over R e raised to negative t over tau when the time is greater than 0. Okay, we can thought of as the complete response as response is equal to natural response plus forced response, where V is equal to Vn plus Vf. Okay, therefore if we add this two, we can get Vs plus V naught minus Vs times e raised to negative t over tau, or complete response is equal to transient response when sa temporary part and plus steady state response sa permanent part, which is V is equal to Vt plus Vss, which is ang Vt is V naught minus Vs e raised to negative t over tau plus Vs. Therefore, we can get Vs plus V naught minus Vs times e raised to negative t over tau. And definition nila is the transient response is the circuit temporarily response that will die out with time. So the steady state response is the behavior of the circuit of a long time after an internal excitation is applied. As a summary, V of t is equal to V infinity plus V of 0 minus V of infinity times e raised to negative t over tau, where V of 0 is the initial voltage at t is equal to 0 positive, and V infinity is the final or steady state of the value. Therefore, to find step response of an RC circuit requires three things. Number one, initial capacitor voltage V of O, and the capacitor voltage V infinity, and the time constant tau. Note that if the switch changes position at time is equal to t naught instead of t is equal to 0, there is a time delay in the response, so that the equation becomes V of t is equal to V infinity plus V of 0 minus V of infinity times e raised to negative t minus t naught over tau, where V of t naught is the initial value at t is equal to t naught positive. Also keep in mind that this equation applies only to the steps response that when the input DC source is DC or constant. Okay, let's solve for the problem. The switch in the figure below has been in position A for a long time. At t is equal to 0, the switch moves to B. Determine V of t for time t is equal to 0 and calculate its value at t is equal to 1 second and time is equal to 4 seconds. So, atong analyze natin duha ka source, which is 24 og 30 volts, which is when the time is time at equal to 0, kan switch is mobalhin sa B dire nga B side. So at t is less than 0, napa sa A ang switch, which is kani nga function. So sama kung determine nato ang v of t, atong i-find yang v of infinity, v of 0, o yang constant time tau. First, so v of 0 is negative when the t is less than 0, where yung switch is nasa A, and equals nasa sa v of 0 positive, which is yung switch is nana sa V when the time is equal to 0. Okay. At t less than 0, kani nga circuit ang mabilin, where na ay 24 volts nga DC source and na capacitor, which is if nakakonect na silang duha, ang mitabo is ma-open ang capacitor, and ang voltage sa capacitor, which is parallel diri sa 5 kilo ohms, will be ayang kung i-redraw na to kanina nang mabilin. So using voltage divider, you can get this one, which is 5 kilo ohms over 3 kilo ohms plus 5 kilo ohms times 24 nga volts. Okay. At t is equal to 0, which is ang switch is nana sa B, which is kanina din yung circuit forma, which is natay 30 volts nga source and na 0.5 milliamps nga capacitor. And if we find some yung time constant, which is ang R na to is 4 kilo ohms, o yung capacitor nga 0.5 millifarad, which is 4 times 10 to the power of 3 times 0.5 times 10 to the negative 3 is equal to 2 seconds. And this yung infinity volt of volt infinity is equal to 0 kung open to the DC man, na-open na siya. So yung volt is 30 volt sa capacitor. Using this formula, we can, since na naman tatong tanan, nakuha na nato itong kailangan nun. So kung ato nang i-substitute lang, you can get V of infinity is equal to 30 volt plus V of 0 is 15 minus V infinity is 30 e raised to negative t over tau nato nga 2 seconds. Upon simplifying, na condition nga if t ay time is equal to 1 seconds, where V times 1 is equal to V 30 plus 15 minus 30 times e raised to negative 1 over 2 seconds. Okay. Can get 20.9 volts. If sa 4 seconds na pod, na condition, can get 30 plus 15 minus 30 times e raised to negative 4 over 2 step response of RL circuit. This we're gonna learn about step response of RL circuit, meaning let's consider RL circuit with specific voltage with in DC. So V of t is equal to V infinity plus evaluated from V of 0 minus V of infinity times e raised to negative t over tau. So kani nga formula kung mag-analyze tag step response RC circuit in which in this case sa RL circuit pod is I of t is equal to I of infinity plus evaluated of to I of 0 is equal minus I of infinity times e raised to negative t over tau. So atong i-analyze ni circuit natin voltage source, resistance, switch, and inductor. So at time negative 0 daw ang switch is closed. And at the moment nga the time is positive t is equal to 0 na close ang switch and then tayo close loop diri nga bahagi. Okay. So summation of V is equal to 0 at this loop. So negative Vs plus VR plus V nga inductor nato. Kung ato ning evaluate ning V nga inductor, you can get this formula L di over dt. So negative Vs plus Ri and kanina po value sa nato ning voltage sa resistor which is Ri. So negative Vs plus Ri plus L di over dt is equal to 0. Okay, we're gonna find current response sa RL circuit. So using this and ato nang divide ra sa N which is this one. So cancel ang L, ang bila na lang negative Vs over L plus R over L I plus di over dt which this one negative Vs over L transpass na dere kanina na. So di over dt plus R over L I is equal to positive Vs over L, and this is a dE or linear in I. Using integration of factor HE integral of kanilang tapat sa I is RL which is R over L dt, and pagawas lang ang constant R over L and integrate nato ang dt which is bili na lang is e raised to R over L t, and ato na i-multiply sa I and get I e raised to R over LT is equal to integral of Vs over L e raised to R over LT dt plus C, which is pagawas na ito ng constant nga Vs over L. So integral of e raised to R over LT dt plus C means ato nang i-integrate can get this one. So Vs over L e raised to R over LT over RL plus C, and can get Vs over L and LR e raised to R over LT plus T plus C, and divide both sides by e raised to R over LT. So can get bilhin na lang igani. So I is equal to B S over R plus C e raised to R over L. Kanang e raised to R over L ato lang negative ang exponent. Okay. This is not a condition that if t is equal to 0, I of 0 is equal to I naught. Ato lang substitute. I of 0 is equal to Bs over R plus C e raised to negative R over L nga t na to nga 0. And makancel na siyang kani siya. So mabili na lang is I naught is equal to Bs over R plus C is nga I naught ang Bs over R bali transfer naught so diri sa left side which is ganyan lang. So I naught minus Bs over R is equal to C. So kung i-substitute back, so I is equal to Bs over R plus times I naught minus Bs over R times e raised to negative R over LT. Which is natin condition nga itong constant time sa inductor is L over R. Substitute lang din. I of t is equals to Bs over R plus times I naught minus Bs over R e raised to t over tau when time is equal to 0. Muna yung atong current response sa inductor. And muna yung atong definition. So I of t is equal to 0 when t is equal to t is less than 0, and if t is greater than 0 muna ito makuha. So V is over R plus times I naught e raised to Vs minus Vs over R e times e raised to negative t over tau. Okay, kung ato tong i-graph tong result ganina, can say that at y-axis natay I naught or I of 0 which is initial siya at t is equal to 0, which is exponentially ga decrease siya ayo until Vs over R, which is this one. And nato siya condition nga if I naught is equal to 0, then Vs over R is equal to 1. So kaning I naught is natog 1 minus e raised to negative t over tau when t is greater than 0, which is kanina siya. So voltage across the inductor. So V of t is equal to L dV over dt is equal to Vs L over tau R e raised to negative t over tau, where atong tau is sa inductor is L over R. Itong i-substitute. So Vs L over R e raised to negative t over tau, which is makancel ni si R of L. Can get Vs e raised to negative t over tau and t is greater than 0. So this is atong step function of an RL circuit with no initial inductor current. So sa current response nagikan sa 0 and time is greater than 0 nag-increase exponentially until V is over R. Ug sa pod kay step response of an RL circuit with no initial inductor sa voltage response. So nag siya initial voltage diri until time is greater than 0. Now decrease exponentially until 0. Okay, so I of t is equal to I infinity plus related from I 0 negative I infinity times e raised to negative t over tau, where I of 0 and I of infinity are initial and final values of I respectively. So therefore, to find the step response of an RL circuit requires three things. Magyapon presa sila sa RL, RC circuit. So the initial inductor current I of 0 at t is equal to 0. So number 2, the final inductor current infinity, and the third one is the final constant tau. Again, if the switch takes place at time is equal to t naught instead of t is equal to 0, the equation above becomes I of t is equal to I infinity plus evaluated from I of 0 minus I of infinity times e raised to negative t minus t naught over tau. If I naught is equal to 0, then if equal to 0, t is less than 0. If t is greater than 0 is Vs over R times 1 minus e raised to t over tau. So, solving problem, find I of t in a circuit below for t is equal to 0. Assume that the switch has been closed for a long time. So, natay 10 volts, 2 ohms, 3 ohm, and 1.3 nga Henry inductor. At that time, greater than 0, ma-open daw ang switch. So, at time is less than 0, the switch is closed. So, let's find the I of t. So, let's find the I infinity, I of 0, and times constant, where I of 0 negative when the moment that switch is closed is equal to I of 0 positive when the moment that switch is open is equal to I 0. So, equal ni sila nga current cannot change instantaneously sa inductor. Okay, at time is less than 0, you can say that igani na ang circuit nga mabuo. So, we can find the voltage, or using Ohm's law, I is equal to V over R, where 10 volts divided by 2 ohms is equal to 5 ampere, which is matang gamiton sa when I of 0 negative is equal to I 0 positive is equal to 5 amps. And when the time is greater than 0, which is ma-open na ang switch, gani ang circuit. So, we're gonna find yung time constant. So, ang L na naman tayo L, given na. Ato na lang pingitawan is yung R. So, using RTH, which is kani siya, ma-open na siyang switch, ma-open na siyang inductor, and kaning voltage source na to nga 10 volts is ma-short. And then kaning 2 ohms ug 3 ohms is parallel. You can say that RRTH is equal to 5 ohms. And we can now use the tau is equal to R over L. So you can say that 1 over 3 nga Henry divided by 5 is equals to 1 over 15 seconds. Okay, we're gonna find yung I of infinity. So since ang inductor is an short circuit sa DC, so ang katong inductor diri kay ma-short. And using Ohm's law, I is equal to V over R, where 10 na 10 volts and 5 nga ohms. Okay, nag-series lang sila. So it is equal to 2 amps. And using this formula, kaya na naman tayo nakuha na natutanan. We have 5 amps and 1.15 seconds sa tau, and you can say that 2 plus 5 minus 2 e raised to negative t over 1 over 15, or we can say just 2 plus 3 e raised to negative 15 amps. Or this is all the discussion. I hope you like it. Thank you.